Okay, to I have been pumping video left and right, but um, so following the chronological order, this is version 2.3. It's a little bit hard to see because FreeCAD scaling is stupid. I'm having a hard time doing with the UI. But this is version 2.3, and I have created a list of things that we need to address in version 2.3. So in version 2.2 there's several problems. Of course we did solve a lot of previous problem, but the main issue with the flimsy structure is still here. It seems inevitable at this pace because it's broke around this area. I don't think I will give it this much clearance anymore because it seems to be severely affecting the structural integrity. I can give it more walls, thicker walls, but should I? Yeah, I don't think I should give it more walls. Like adding in thickness is a good idea, but I think the main I think adding in more structure would resolve the issue, but how thick does it have to be? Because clearly 3 millimeter isn't enough, and it's just gonna flap around. And yep, that is the first thing. So I have to decide in this version to whether to enclose it all and keep the same wall thickness, or significantly double, probably double or triple the thickness, and give it more room for the hub to cool down because this thing get pretty hot. Remember, this thing also take care of the charging of the laptop. So so that I can just lie in the laptop and plug in a single cable from the laptop charger to the hub. That is it. All this cable will be automatically connected once I slide the laptop in. That is the first issue we want to address. But I think that this may not be version 2.3. Hold on. I think this should be version 3.0 because of a major. No. 2.3 is a good one because after careful consideration, my desk doesn't allow for this configuration to be exact. It is just too thicker than I expected. So I cannot slide the laptop to my right. I still would have to do it on my left, but I would do it in a smarter way. So this is full size, 250 millimeter. I would add more bolt and connector, more holes, more mounting holes in this section, so that the laptop doesn't protrude too much into my left and minimize the chance of me accidentally hitting the laptop with my knee when I move around. I think, yep. So it will be a major design overhaul, and I think we should address that first and foremost. The rest of the design is fine, I guess. Let's see. Oh, and we also learned that we shouldn't do the hollow wall because it seems to be affecting the structure integrity. So we shouldn't let the slicer do sparse infill because it is easy to be clogged up on small details like this. Yep, printing slowly has its demerit, but it cut back on the snagging problem, because the main problem is the tool head keeps snagging on this part and causing fatigue in this area. So move the entire setup back to the left, which requires me to learn about, so the vent, yeah, this entire thing will need to be mirrored to the left side. So let's do that. It's time to learn something. How to mirror entire yeah, mirror the entire body. This is what we want.
Hello everyone, welcome back with FreeCAD basic tutorial lines. The next, click close. To convert into 3D, we can use Petal. Click OK. To mirror in part the subject, like in here, this not feature, create a mirror feature, you can click part the signs tools, we can use this command, create a mirror feature, you can click. But with this feature, we need to intersect between the mirror and the object, like in here, this not intersect, and you can click OK. So it will be failed. To fix, you can change for plans, select reference, and we need to select at face, like I will select at this face. So it will be automatically mirror, but intersect between the object. Click OK to apply. I will undo. The other option, we can use part tools. You can change into parts in here and use these tools to mirror the object. With the mirroring select and shape, you can click, and the next I will select in path. With the mirror plane XY plane, this for default, and for distance we set into 0. You can click OK, so it will be placed in the bottom here. You also can set distance in here, like we can undo and use this tool again. Mirroring path and mirror plane XY planes. For distance in here I will set into 20, and you can click OK. So it will be correct distance 20 between these two objects.
Okay, let's try it. This is version 2.3. So we go into part, not part design, and go into part. What do we do now? Select something about mirroring. This icon I remember. So press it in. This mirroring. I think they're asking we are mirroring to what, right? So we want to mirror in the XZ plane. Should I just do this? Okay, it doesn't work like that. It definitely doesn't want to work like that. Let's start again.
Also, distance in here I will set tools you can change into parts in here and use these tools to mirror the object. With the mirroring select and shape, you can click, and the next I will select in path. With the mirror plane XY plane,
so we are selecting the final operation, not just the thing, right?
This for default, and for distance we set into 0. You can click OK, so it will be.
Let's try again. Part, mirror, final feature should be the fillet 001, and XZ plane. Is it good enough? Okay, we have one already, and of course it's not what we want. What the hell is going? No, back. Let's do it again. Mirror, select the final operation, XZ plane, and we give it an offset in the Y direction of 30 millimeters, and press OK. Now Okay, this okay this is making my brain hurts a little bit. Oh crap, I am very stupid. uh, this thing final operation actually plane, give it a more generous offset of 50 millimeters. Okay, now it is separated, and what we want to work is the one on the right, not on the left. So what happened if I just export this? So export at version 2.3. We're gonna save it. Version 2.3 mirror. Oh, okay. It knows that we are. It knows. It considers this thing an entire part, an entire body of itself. So I think the result will be favorable for us. Oof, I'm trying. I should talk. I should talk slower and in a deeper tone. Yep. I should. Okay. So this is what we have, which is perfect to what I want. This side is entirely flat, and I can mount it to the side, the left side of my desk. That is the first thing. This so, and I of course can still make some cutout. Yeah. Everything seems to be in order. Yep. I'm worried about this, but it's gonna be fine, I guess. So let's try something. In the third version, I want to maximize the scale of in which I can print this. So I'm gonna tilt it 45 degree only, and make use of more diagonal. To be honest, it doesn't make much use, because because if I go with this design instead of a horizontal design like in this video, so this is a horizontal design, which is super nice. Like, go in, like, do you even notice how smooth it is? I encounter a lot of friction when I slide it in. I don't know if he used I don't know if he need to have accurate dimension in the back or something, but this is really smooth, and it actually improved a lot on the user experience. Now I used to try, this is version 2.0, 2.1 and 2.2. I tried to make it vertical, sit on a flat surface, but due to the constraint, the limitation of my desk, I can't do that. My desk is populated with screens, with monitors, so I cannot have enough vertical space for this setup. And because I have a tray keyboard, yeah, I have a keyboard tray, so I can't even do this, because in order for this to work, the entire dock would have to move when I pull out the keyboard, and it is very cumbersome. Let's not go that route. Yep. Locking mechanism is nice. Not necessarily locking, but being able to push the laptop out to eject it is nice. But I wish there was more material on this. Let's see. Let's check out the page. Laptop under desk dock. We have Thunderbolt cable mating mechanism. How did he do that? I wonder. So it seems to be some sort of clamp. These parts are definitely 3D printed. He have two Thunderbolt dock, I suppose. Okay, two of them. And I guess this is the push out mechanism. So once the laptop moves in, it straightens this bar and push the button out. Okay, so quite a bit more complicated than my design, but seems very reasonable and well thought out. What did he do with the did he add some sort of bearings or sliding mechanism? Okay, this is the part this is the money part. I bet he's no way. This is actually good. So he used precise measurement. So he precisely measured the whole thing. But the mechanism for when it connects to the laptop is, let me roll back, is different. So I bet he is giving it a bit more wiggle room. Yeah. So the distance between the two parts are well calculated. But I don't think this is a very elegant solution, to be honest, because a lot of printed part with not that many value added, to be honest. Like I can use glue and epoxy. Of course it is not glue. Of course we need some kind of solvent and getting physical, like a Dremel, to get the epoxy removed. But yeah, this thing seems to be a lot of over engineering, and the performance it brings isn't necessarily better than from DIY Perks. Yeah. Where's DIY Perks? Yeah. But I do like the ejection mechanism. It is good. Are there any sliding mechanism also? Because okay. Okay. So he bolted the part down. So like okay. This explains why his project works so well. So he basically mount the whole setup to the underside of his table first. Then he slide the laptop in. He plugged the entire setup without the bolt into the laptop. So now he will know that it will definitely fit perfectly, and then he screw it down. So instead of using epoxy, he used the ability to adjust the screws to give it the perfect fit for the laptop. This is much more well thought out than I expected, and the rail system is clever, to be honest. Because smaller printer can also do this. You don't have to own an A1. You can definitely print this on an A1 mini. It is clearly well segmented. And I think it is much more. Yeah, I think this is much more universally adjustable than my design, because you see, you don't have to find a fixed dimension for this, because you can just mount this thing far further depending on your model of laptop, and you can mount the entire thing deeper if your laptop is longer in this direction. It's a very elegant solution, I must admit. It hasn't crossed my mind to approach this. And yeah, it would work perfectly with my intention also. I can still mount the entire hub near it, um, and nothing, basically nothing would change because I still have the ability to mount it down here. But to be honest, I would still think I would still need some kind of glue to hold the thing together. Yeah, but beside that, this whole thing is a lot better. Yeah, this whole thing is actually a lot better than my design. I can't find anything to criticize or say that is worse than my design. I have basically wasted a spool, an entire spool of filament just for prototyping, and I don't have anything present to show. It fucking sucks. To be honest, it actually sucks a lot. Mm. The only reason I can't and I still haven't download this thing and print it right away is because my desk have a draw type of system. I can, I think I can make it work by mounting it to the lower section. So every time I have to pull out a laptop, I just bend my back and slide the laptop in, maybe. Because this is really elegant. Damn it, why did I waste all those time designing and drawing? Of course, for the sake of learning, it's not wasted, but oof. Okay. I'll copy the image. This is a valuable lesson. Can this setup work with vertical dimensions? Probably a bit harder to work. No, not exactly, because he doesn't have to get the fit between the chassis and the port right the first time like me. He can just build a frame, add in padding material, so like some sort of glue, paper, anything would be good. Um, I fail to see how this would work in a vertical setup, but this thing beats my design in every single aspect. I'm not gonna lie. Oof, I'm gonna have to download it. Dang, I sucks. Okay, download all models. Model origin. Okay. But the great thing is this thing doesn't need any. What the thing is, this setup isn't laptop specific, so my configuration only works for ThinkPad T14 Gen 1. This configuration works for all laptop. You just need to remount the rails, and that's it. Dang. Yeah. Yeah, I would need to sign in. What am I even doing? I'm trying to not to fall into the sunken cost fallacy, but this design bypass all my hardship. I'll try to justify it, but to be honest, it's pretty hard to do. I can try to make one that is a bit more compatible with my setup. To be honest, okay, let's take a step back. Okay, yep, is definitely enough cable room for the laptop, lower laptop position. So the ports would go in this way, and then would go this way. I would just need to bend my back. Can this thing works even without? Can this thing works even with a cable tray? Let me check. The design. This design may even work because I expect it is thinner than my design. And if it is not, I can probably copy it and make it fit. That is really hard. Yeah, it's very close, I must admit. I had to admit this, but yeah, he got the point. Should I add some kind of eject mechanism? Because I actually like that thing a lot. But how would I design a good eject mechanism for so horizontal setup will still works if I can reverse engineer or remix it. T14 is actually quite thin. If I get a mechanical keyboard, it wouldn't fit, but overall it would. If it still works, I think I can stay with it works. And just put I must yep. Okay. Well, I think we all know where this is going. Version 3 will be a horizontal one. But okay, let's just assume that we don't have space for a for a horizontal one. Yeah, let's commit. Let's commit because there are these options, these solutions are definitely inferior.
Right, so I just
So like,
pretty basic laptop slots into these holders with cutouts for cables, as well as add some padding. Yes.
Just I can with the lid closed before I start. Good work. What about the phone? Ooh, that's snug. I might just add headphone jack support in just in case one day I need to use it. Oh, how long are you? The LAN cable has a little tab. That's kind of tricky trying to flick that out. I mean, think about that. Trying to get your finger in there.
Oh, that's not far away.
For my final design, I'm going to make a cutout at the top so I can plug in my main cables and then slot the laptop down into the dock. On the other side, there's only a USB-A port, and since this is used for USB keys and chunky dongles, I'm going to keep the support in place because I'll be plugging them in after mounting.
Now, if you don't have a 3D printer at home, you can head to sites like PCBWay.com, where you can upload your 3D model, select the material that you're after and the percentage infill for strength, and get an instant quote. They also have other advanced manufacturing methods, which is not helping to keep my future project list any smaller. Thanks PCBWay for sponsoring today's video. Let's check out my print.
This is what I love about 3D printing. I had an idea Wednesday night at 4 PM when browsing Amazon, and within the hour I had my first prototype printing.
yeah.
Yesterday I made
the
some change-
Amazon option will definitely be worse than what we can custom make, because laptop it doesn't come in one dimension, and your need will vary a lot. Still, I think this could be made so that everything can be customizable, perhaps. They do make adjustable laptop dock. It just doesn't come with a tailored option of every single port being automatically connected. Yeah, that thing isn't commercially viable yet, because there are so many kind of laptop.
changes with around an hour's worth of work and had the final
Still-
product sent to the
It could be custom made. So there's
printer. Now I printed this in PET G, which is stronger than the standard PLA filament type. And it shows.
Oh no. What is it? Going all the entire way to the freaking.
Oh, it's gonna breathe so well. Get out of here! Oh my big.
Wait, so he
Oh,
still
okay.
have to
Well, I
plug
guess
in
that
the
answers
cable.
how strong it is. It can hold the entire way to the freaking table.
Seems like that.
Wow. First test. Oh. Oh, dude, it just glides in there. Oh, it's gonna breathe so well. Get out of here! All my big chunky USB keys fit.
Good camera work.
Oh,
I
and the
love that.
cables. The feed through acts as like a cable holder. Nah. Too good. Too freaking good. Nah, man. Nah, fan. Nah, that's too good. That's too good.
Decide last week?
Yeah, this option would
Obviously, I've tailored it for a snug fit with my 2017 MacBook. There are a few harnesses available for different plugs, including genuine app. Use the make harness function to create your own to match your plug housing flush. The larger pocket, the key, and you're good to go. If you make the community hub option, but of course, you're also welcome to subscribe.
Okay.
Cheers, folks. Bye.
I think all these up Okay, this tutorial has been very helpful for me, to be honest. Yep, it's with this years of but we learn as we go, right? So this setup wouldn't be very meaningful, to be honest, but 150,000 for this kind of learning experience, I think it is worth it. So I'll just turn it off. But I think I can turn it on, right? Turn it on, so I can. So does everything I made on the left get updated on the right? So let's try this. So I want to add a saw and create an upper bar for the Thunderbolt cable, Okay, so let's clear that checklist first. Still have no clue how to navigate it smoothly. Okay, this is the original, and it would be laptop ports pocket. Okay, this is the one, and I want to add a bar over here, a bar that should be like 3 mm thick. Yeah, I think I have space for 3 mm. So we will add a line tangent to this one, horizontal and tangent. Okay, and there should be another line. Yeah, there should be another line from this to this, and we will have to trim. This is solid. This should be solid now. So which part do we trim again? Because this has to be an enclosed space, so I still can't find that form of enclosed, because this is an enclosed wire. I can visualize it, but what happened if we close the sketch right now? Nothing happened because there's, yep, wire not closed. So I'm having a hard time visualizing this. So I think we should trim this and this and this and this. Yep, yep, definitely it is closed now. So we just need to add the constraint because it is able to move a lot. So back, this line and this line should be vertical, should be, yep, 90 degree here. So the shortcut is N. So yep, that is correct. Similar to this one. This one is actually okay, but just need a intersect. So this one and this one is coincident construction. Okay, so like this one and this one coincident. Okay, it doesn't work like that. No, let's focus on this one. Okay, this one moves a lot, so we put a we should constrain this one down. It moves like this, right? So this and this should be at the same point, and this and this should be 90 degree. Fuck. Okay, let's take it back. This one and this one should be at 90 degree. Okay, so they are definitely at 90 degree. Perfect. And now this one and this one should be coincident, not like that. Okay, this one and this one should be coincident. Okay, I need this one to stay to stay in one place. No, because this has this degree of freedom and also this degree of freedom, so we need to lock it down. But how? Well, because it is moving, it is still in 90 degree, but it is moving. So okay, I think I need to lock this point down, but how do I do that? Okay, block this from moving. I want this one and this one to join. Okay. There's a lot of degree of freedom in this direction, so we're gonna lock it down. This thing is fixed, I presume, but the entire right section is not. So can I just add a dimension for it, so that only the upper part is now moving, and I can add another dimension for it. So now it doesn't have, yep, this one doesn't have any degree of freedom anymore, but this one does. So now we can select the 2 point and use the coincident constraint. So yep, the lower part is definitely constrained, and we'll move on to the upper part, which is this. And we'll set the distance from this one to this one to be 3 millimeters. Yep, only the upper edge move. Okay, perfect. This is exactly what I want. A place for the Thunderbolt cable to plug in and have more surface area. The lower part is already good, so no need to adjust that. Why do I have this constraint? Can I just delete it? Okay, I can't. Okay. Is there any more warning or selection? So I can close it, right? It's recomputing perfect. Okay, this is okay. It has already updated, as you can see. Yeah, nice. It updated nicely. Now, should I add a chamfer for it? Let's try. This one is the old version. And my mom is gonna be pissed when she find out that I use my money on studying stuff like this, because this thing doesn't actually make me any more money. And okay, I already added the one. I think I can put a chamfer in without affecting any functionality. It doesn't even block the LED light. Yeah, it won't. It really won't block the LED light. So let's go to, sorry, it's fillet. So what does the fillet do? Okay, definitely not this one. The fillet. Okay, this one. So we'll select the other lower edges. This one and this one. Okay. Okay. What? Okay, something is broken. Part mirroring links object go out of the allowed scope. Part mirroring. Okay. So let's just delete the part mirroring for now. Yeah. So we do the fillet first. And press OK. Okay, no error messages. I think it's a problem with the tree view. I still haven't figured that out yet. Okay. The laptop charger works like a charm. No need to edit anymore. This relate added, so improve on the performance. I think I can improve it a little bit more by fine tuning it instead of just select all of them and give it a 1mm fillet. How do you say that word? First thing is chamfer.
Chamfer,
Chamfer.
chamfer, chamfer, chamfer,
So it is chamfer. So it is chamfer, not chamfer. I am being very dramatic. Chamfer is the correct term.
chamfer,
Chamfer.
Chamfer. Okay. Chamfer.
chamfer,
Chamfer. Okay. Good one. Mid in the sense foot of furrow, cut me along the edge. So corners are slope rather than beneath. Yeah, this is chamfer. So is fillet. Hope they don't understand about filet mignon.
fillet,
Fillet. Fillet.
fillet,
Fillet.
Okay, I have been going back and forth between American and British.
Fillet.
Fillet.
fillet,
Fillet. Fillet. Fillet.
fillet,
Fillet.
fillet,
I think fillet make a bit more sense to me. Fillet. There should be another. Am I making a spelling mistake? Let's check that. So we go back to part design. This thing is called Fillet. Fillet.
fillet,
There should be another meaning, but I can't find it. I don't think the terms in cat has anything to do with fish, but okay. I won't close this one out because I need space for the other part. I don't want to cover anything. Okay, so this one is remove. We got this. Creating an upper bar for the Thunderbolt. Control Shift S. Okay, we will now move the vent up by 2mm. So this is the laptop vent cut out. No, I need to press into the sketch. Laptop vent, this one. Get it to the right one. Why doesn't it show me the dimension? Okay. For some reason it doesn't show me the part anymore. Why is that? I don't know. Let's not do that. Interesting. So okay, I need to enable. No, not that. This one. Okay, I need to enable it so I can see what's behind and seeing it head on. Dimension is good, but I need to move it. Move it. Disney, please don't copyright me. So I just need to fix this 3 into, should I just let it close? Let me check real quick. This thing is really close, so I think I should just let it go. No, 2mm is good enough. Yep, 3mm is okay too. So I can just cancel, delete this parameter, make sure, oh, I need to create external geometry. No, I already got the geometry, so this thing and this thing should be tangent to each. What the heck? Is it just, let me check. What the heck? What is, okay, I think I see what's going on now. So it hasn't updated, so it still see the old version, the old holes. We just update it by using the tangent command, so the vent is shifted upward by 3mm. Shift upward by 3mm. I need to be slower. Yes, it is recomputing, and the result, yep, what, it should be an error, right? Because an edge has been disrupted. Yep, let's just delete the fillet. So this is, I think this is a true hole now. Yeah, the fillet has been giving us some problems. Okay, length, should I make this thing full length so I can make use of the back? Let's see. This is current setup. Have the entire structure in the middle. But the laptop still, the problem is not how the problem is not about the length of my prints, but about the protrusion of the laptop. So it is now being able to move my laptop as far back, move the entire dock structure as far back as possible, which means putting screws in this area, and that's gonna be a challenge. I'm not gonna lie, that's gonna be a challenge. Now I have already ordered some screws, so I think we can do it. Add it to a checklist. Add screw holes for M3 screws. This thing is countersink or countersunk. Just countersink screws. Yeah. And I just buy like 30 of them so I can standardize all prints. M3 is like pretty easy to drill by yourself too, without needing another pilot hole. Okay, all that aside, Slam 3D taught us that we shouldn't just remove material to save on cost, because this is not injection molding. Injection molding do that not only to save material but also to prevent warping. But in 3D printing, it is very easy for the structure to be damaged. Now, I have to agree with that. But the cooling performance of the dog is still it is still important enough for me to wear these cutout. So I would still have those cut out. So this fillet is for edge. Okay, a fillet is for let's give it a name. Fillet for chill pork. Okay, give it a name so we don't accidentally delete it. This one is for the low one, so we can cancel that. Chamfer 2 Thunderbolt port. Okay. Chamfer 1 not chamfer. Okay. Chamfer 1 where the heck is it? Okay, it is the chamfer that is holding the structure. I don't think it will survive, so let's just delete it. And of course it break these things. Wait, what why? Oh my god. So can I just move the order, or does it have to be? God damn it. Why, KiCad? Why do you have to make such a stupid workflow like this? Now of course I can easily redo this part, but why did I deleting this thing? It has nothing to do with this part. Why does it just disappear? Who the fuck designed this? Who the fuck designed the UI of this thing? I know there are a lot of good coder who, let's face it, solve the topology naming issue and all that stuff, but the UI is fucking stupid. Like, this is the reason people go for Fusion 360, even though Fusion is like malware to me. Why the fuck does why just why? It's like the developer of FreeCAD is paid by Fusion 360 to make it as terrible as possible, so that it can easily advertise. They can advertise their product. Okay. We're just gonna select it again. Let's try that. So we're gonna release the two edges. Okay. We're going to select mode. Select this one. And this one. I still think it will be broke. And for some fucking reason it works. How? I know this is a step behind, but why do they have to make it like that? What if I want to edit parts above? I don't want to do the whole thing again. Dang, like pardon me if because I don't know a lot about workflow of CAD or parametric modeling, but it's super counterintuitive. They design this thing only for people who made a lot of money and have familiar with the workflow. Because to be honest, if they do, they would probably buy Fusion already. Okay, the road to free and open source is challenging, but I'll give it more time. Okay, still works pretty well. Now, I cannot avoid the wall thickness issue, so I must add the thickness in. I can, yep, 3mm is not enough let's face it, 3mm here is not enough. It has to be like at least 10mm, so like a full centimeter of material. Yep, like something like that, so I can reliably print it. Yeah, double. I think doubling would be enough for this case. Of course, the easy approach would be to fill it in and block the heat dissipation. Okay. Maybe one of the main reason my design failed is because I skimp on the base material. Let's try to address that. Of course, I will still give how thick is a full centimeter of material. 5mm is actually pretty thick to me. Yeah, 5mm is actually pretty thick to me, but I can still see the printer snagging onto it. Okay, the old design can work on 3mm, so this one should also. Now, this is the tricky part. The whole design is mirrored left and right, but the current design is focused on downward position, so the side with a lot of ports will be the up side, so we have to model accordingly. Yeah, so the original and one is moved back. It is not correct anymore, but I will still use it even though the LED is now covered. Yep, the LED will be covered. It wouldn't matter as the main feature as the main feature is still there. Okay, I need to fix my errors using step measurement. Give me a second, I will do the step measurement. 21.3mm. 21.3mm. Okay, let's go with that. So this will be, yep, I think I should model it separately, right? Modeling it separately to give it as much structure as I can. Yeah, let's do that. 21.3. Laptop, no, hub ports pocket. should show us the product at this point already. There should be an entire block down here. But it's not showing. Oh, okay. I would need to offset it again. Yep, the sketch is too low. It is too low at first, so we need to offset the sketch upward. Yep, but below the surface. So let's do that. Enable the view and no, set the sketch. Attachment offset. Okay, set email attached to the XY plane. Position. And for some, okay, it is actually easy in this case. So instead of 60mm, you can go up. $113mm, close, but I think it will do. Now the sketch is in that direction. Perfect. Yep, the bottom one hasn't been cut out, and we'll change the pocket operations from 2.0 to 3mm, and let's see the result. Forgot about the direction. Not reverse. Reverse, not. Let's try not reverse. I cannot see whether it is cutting upward or downward. Okay, we got this. Direction has to be reversed. Okay. Okay, we remodel. We have HDMI ports. Damn it, I forgot again. 21.3mm from this edge, yeah, from this edge, so 21.3mm, and the other edge we will not be using. Yeah, we will not be using SD card because company's laptop, so we don't want to access that. Oh shh. We don't want to access those parts, the mass memory. 43.4 millimeter. Yep, 43.4 millimeter. That much? Let's double check. Give me a second. April 3.4 should be is a good number. Let's go with that. So this is for the charger and the HDMI port. 21.3. Yeah, measurement is so good on this side. And I think we can chamfer it. Chamfer it down. Good one. And how about can we make another sketch with the same operation? So we'll select this, and can we add a sketch here? Of course, the same plane is the XY plane. No, I want to add it to this operation. Can I do it? I cannot, it seems to be. I want it this stage. Can I add it at this stage? Okay. Select attachment, attach to display. No. I think I got the Linux experience with this thing also. And I think I have given up on creating a work for Linux, because Linux is a fucking pain in the ass to use. Basically everything you got is, yep, is what I know, go figure it out. And I don't think that's helping the free and open source community at all. I don't think the Linux user care because of elitism, yeah. They believe they're the best, so yeah. I have no argue with that. I'm not even that good with the computer, as you can see. Okay, now we got this. We need to measure the lower dimension, the dimension of the USB port. So measure 36 millimeter. So we'll create a rectangle. Yep, create a rectangle. The tip should be tangent, no doubt about it. But the distance should be 36 millimeter. And on the other side, step measurement is incredibly useful when measuring things. I just learned recently, and that is a game changer. I don't have to use the depth gauge. 28. Okay, I put it to 29. 29 should be good. Millimeter. And close the sketch. Use the pop. Okay, I have to move the sketch up. Okay, pocket operation. Give it a pocket dimension of 3-4 millimeter, and maybe reverse. Yep. Okay. Gonna need to come back and change it a little bit. I may have select the wrong. Yep, I've selected the wrong reference. Delete. And of course delete this one also. We're gonna need new. Let's turn this off. Okay, we're gonna need new reference. We should reference the inner. Yep. Yeah, we should only cut out the inner part. Hope I'm not messing anything over here. Okay, I definitely messed something up. Let's try again. Because this thing is now flush with the surface. Yep, it is flush with the surface. So the cut out would be, will be very flush to it. Select these one should be tangent, and this one should be tangent. Close sketch. Yep, this is perfect. This is exactly what I want. Step on the B. It's getting late. Okay, few more things. Move the vent up. Okay, already done this. Control S. I already learned how to do this, so clear. So issue. Okay, I'm solving this one. Thin structure, the issue with thin structure. So now we add a much better top and bottom structure. I think I will need to address the center one. Now the vent. Okay, this should be USB, right? hub USB cut out. I don't think I will name the sketch because I don't know how to reuse sketch in other operation yet. Okay, so we'll select the vent hub and charger vent. I think it is this one. Yep, I use the same vent because it will be cut in at roughly the same depth. Yep, because if this one is cut in, this one will be. Now let's go back. We may have been went a little bit too far with this thing, so let's correct it. This thing should be just 9mm. Should I even add a cutout for this? Yo. I really like having a cutout, but having the printer just banging this stuff all over the place isn't nice at all. You know what? Fuck the sketch. Nobody will be able to see it anyways. Oof. Yeah. I don't care about the vent on that section anymore. And of course it affects the chamfer operation, but I think I can delete the entire operation altogether because yep, I don't need that chamfer anymore. So the port, of course it will be broken, but now we know how to fix it. Is to reselect it. What the heck? Wait. Just for Thunderbolt port. So why is it selecting here? 1.49mm. Okay, we got that. Wait, it's a chamfer, right? Cancel. So we want to delete this thing, and in turn it will break this. This thing is for these two edges and the edges below and the edge below this. Move. No edge specified. Okay, so let's for Thunderbolt port, right? So we add a chamfer to these two edges again, and it is back. The fillet for the charger port is broken. No, where is that? H104. Okay, I remember selecting more than one, so let's remove that. Change into select mode. It's not choosing anything, and for some reason it still exists. Okay, FreeCAD, I'm gonna need some explanation, bro. This one. Perfect. Save. Remember to save your work. Wait, where's the? Okay, it is added later, so a bit confused. Nine warnings. What the hell? I think yep, those are old ones. Let's see. Okay, back to the checklist. Okay, we have already solved the issue about tall and thin structure. Now we want to add screw holes. Add screw holes for the M3 screws. Yep, I want to add those. And where do I add it? I want to add it as close to the forefront as possible. Let me cross check this thing. So 250 millimeter should be able to leave out the final vent, so some vent will never be reached, but those vents are small, so should I give it space? Give it space so it can breathe. It will intersect with the current section. So how about no? Yep, how about no? People put their laptop on their bed all the time. Everything will be any hindrance to the laptop. This isn't a powerhouse anyway. Okay, there are those overhang I think it can be negligible. Let's focus on the design of this thing. Before we do that, let's check the laptop housing to see that laptop housing. You see that this is 250 millimeter. Yep, close the sketch. I want to add 3, M3, so like 3 should be a good number. So 3 by 3, should I do that? I wanted to add it as far as possible. This may be a good opportunity for finite element analysis. I know that FreeCAD have that function, but I haven't given it a try yet. Okay, we will create a mounting section So we select this plane. Nope, I want to from this side. It will be a sketch that contain a rectangular shape. Should it be rectangular? To be honest, I think it can be round. Ooh, nice. How do I make it straight? It should span for. Ooh, okay. This thing actually scale and not just. Okay. This seems to be fixed. The scale seems to be fixed. Yep, I think a rectangular would be enough. Will be sufficient. Just put it right there, and we're gonna create some reference geometry at these reference point. Okay, cut into. It will cut into. Oh, I think I should be careful about this because I don't want it to cut into the path of the rubber feet. Yep. So the path of the rubber feet is likely below. Yeah, it is likely below. Slightly below this edge. So how long is this? Let's give it an estimation. So 2 centimeter. Yep, 2 centimeter. 20 millimeter. Alright. So we got our first constraint. It should be 20 millimeter from that edge, so that it will not interfere with the system. This part can be tangent because yep, and I believe it is fair to be tangent. There is nothing to be worried about structure integrity after this point. At least I hope so. But this will give us a bit more space. Yes. And the distance, the length of this M3 bolt, so we should give it like 6 millimeters, so a bit more clearance for the head to go to. Let me check again. I use the KA which have countersink. I don't remember what I ordered. Is it the 18 millimeter or something like that? What the heck did I order? I'll check the phone. So KA 8 millimeter. I don't know if it is a little bit underwhelming for this kind of load, but this yep, I think it's this one. D, I don't know, D, no, not, that's not the D link, that's not the K. What the heck is this dimension? So that is at 2 millimeters, so we have enough clearance to make sure the head doesn't protrude over. Okay, diameter of the head 5.3 millimeter, so giving it 6 millimeter should be okay. Let's give it a 6 millimeter clearance. It can okay, it can still move that way, and I think this distance is good. Oh, okay, wait, I can give it another distance because this is down by 20 centimeter, look, 20 millimeter, so let's give this one the same kind of same number, 20 millimeter, so it is a bit more symmetric. I don't know why FreeCAD does this, like can it just do something a bit more, but I guess in computer there is no concept about no space. Let's see. Yep, this will do. Now we need to create, yep, this is a good cutout already, so let's focus on cutting this out. Pocket operation, dimension, maybe have to reverse it. Yes, 4 millimeter, is it enough to go through all the material? Definitely. Okay, it's good enough to me. I can chamfer it later, but now we'll call this mounting window. Now I need to create the mounting hole. Same plane. I want to create it from this side. Select reference. I should take the outer edge of this guy. I have to take the inner edge, but good enough. Here. Now I have a reference for all my holes. I will now need to create 3 equally spaced out holes. And I'm a bit worried because this is the layer line. The layer line will be this. So kind of terrified that it wouldn't be able to hold. But I guess I have to trust it, maybe. But the old system seems to be holding up pretty well. The plastic, yeah, plastic is much stronger than I expected. And I think my judgment about the depth of this 19 millimeter, so I could have gone for a thicker one. Let's just hope it won't bite me in the ass later. Now let's create 3 points and then use the whole creator. Let's try it. So I just create a random point under contract. Oh yeah, doesn't matter now. And I want to create a hole. Should I just attach it to the face? should attach it to the face because countersinking feature is bad. It's really bad. So this one, sorry, just pressing in map mode front. Yep, but instead of that I choose yep, I'm gonna have to break the rule a little bit and create right on this surface. The reason I don't do that because it is really easy to break the mapping when you change some parameter, and it has been a pain, which leads me to the reason why I create a different version. It seems to be mapped correctly. Select the whole right here, close, under constraint, yes I know. Now to the whole generator. What the heck? Show me. Cannot make face from profile. Yeah, it have a point. You cannot define a surface with just a single point. Let me try that again and create something a bit more specific. Specific is a circle with a diameter of 3 millimeter. What the? Okay, got this down. Got it. Whole generator. Now I want to be a profile ISO M3 current standard depth is enough. Reverse taper, no, that don't need to be threaded. Cutout type is countersink, not countable, countersink. And let's check with this thing. And degree, thickness of the head. What does the cut out? It's the diameter of the cutout, right? So that is 6.10. Also the outer, the big diameter over here. And he said that you know what, a little bit bigger doesn't actually hurt. But oh, I cannot adjust this. Look, wait, what? 5 point. Yeah, I can still adjust this. Okay, 5.3. Oh, just go back to 6. What happened? Is it okay? I think it's interesting. What the? I just want 6. Number 6. Can it do? What? Number 6. I just want number 6. Okay. How does that work? Okay, can I decrease it down to 5.4? No, 5.5 millimeter is good, because I don't trust the accuracy of this. It's gonna get squished down. That okay, can see angle. drew point must be flat. Yeah, this is, but yeah, drew point, yeah, I'm drawing flat into the surface. Alright, seems to be good enough to me. I'm not creating any thread on this, so okay. Got pretty nice hole. So let's get serious and create a bunch of more holes with that diameter. The sketch doesn't have any reference yet, so gonna make wait. Yeah, I think it doesn't have any reference yet, right? This one, select this mode, and of course this one. Back to X-ray mode, to rear. Okay, this is what I'm working with. I will create a construction line. No. Okay, I'm trying to. Let's create a line first. Ooh, okay. Okay, auto constraint, I love it. Dead center already. Now we'll just create a circle. Ooh, okay, so GN, oh nice. Create 3 of them. Ichi, Ni, Sun. Okay, we got 3 of them. And that, okay, now this one and this one, you should this thing. Okay, now this thing doesn't have any degree of freedom. Does it? Doesn't seem to be, because the white one can move. Let's pull it out. Yeah, this one cannot move anymore. It is dead center, and I want this one. So I select the center, this one, and this one, and this one to be symmetric to each other, so whenever they move together. Perfect. Now we just need to determine the distance and assign a distance to a single branch. So what is the distance for this? It is 90 millimeter. So 1, 2, 3, 4. Let's divide it. So 90 divided by 4 give us 22.5. So let's give it a dimension from this point to this point. It have a dimension of 22.5 millimeter. And let's verify it again. Let's take another segment from this point to this point. It is 22.5. So we got it. I mean, I am so smart, baby. Small victory. Got it. So close, and 3 beautifully made hole is here. I feel like I have wasted a bit. Yeah, I think dividing it is not a good idea, because the main point is to divide, space it out as much as possible to give it more space, right? So I will make this circle and this line be tangent, so it will be a tangent, and close it so we can maximize the window that we have made before. It doesn't work that well. Why? Is it taking the center? No, it's not taking the center, right? Yeah, it is off center, but why does it take, why does it look like that? Okay, let me check it out real quick by turning off the X-ray. No clue how it can be misaligned like that. Is it due to my perspective? Let's try this. So like, so in perspective view it is okay. I think that's why people don't use perspective view. Orthographic view should be the correct one because it doesn't bend stuff around. But why is it not centered? It's driving me insane. But yeah, it would still affect the would it affect the drilling? I don't think so. So I think we can shift a little bit, right? So look at the center is still here. The screw head is gonna be a little bit smaller than that. I think we can still put it in. Yep, I think we can still put it in. But to be safe, I don't want to take that kind of risk. What the? Oh, okay. It is access violation. What the heck is this? I want to access my sketch. So remove the tangent. Let's give it a modest number, like 3mm, and call it a day. Yep, good enough for me. Actually, it's pretty good, to be honest. Let's give it a proper name. Let's save it and create some chamfer from this point on. So we put this thing on its head and start to round this thing out. Okay, this thing and this thing. How much can I round it out before it get destroyed? Chamfer, this one. So how much can I actually make it? How much is my GPU running? It is getting laggy. A lot? What the heck is running? FreeCAD. It doesn't show CPU on GPU on Task Manager, but what the hell is Microsoft Edge using? Microsoft Edge is still using a shit ton of resources. Okay, stop now. OBS Studio, a lot makes sense. Oh, just get laggy a lot. So 5 is a bit too much, right? 6, 7, 6.99. Okay, looks good to me. Yep, looks good to me. Let's cancel that. Let's create. Let's focus. Let's fine tune. This is the end game now. We're in the end game. Everything is perfect. Everything is to spec, and this is the cosmetic phase. I'm gonna make it nice. So 6.99. Boom. Make this one. No, I'm gonna make an image. This one and this one. To be a good number. How about 4.5? Is it good? 4.99. Oh, it's even better. Okay. This edge won't get round out. But the inner edge, yeah, the edge on this thing can be round out. So cancel first. Oh, Control Z, Control Z. No, Control Y, Control. Access function. Fuck you. Control Y again. Why don't you let me do it? Oh. $4.99. Okay. Now we select. Yeah, I guess it's fine. We can select this edge. Flame. Let's give it some number. Okay. 2.99. And that edge could be also be applied for other thing. So let's go back to fillet 03. I think we can also apply it for this one and this one, since they have the same properties. Let's see. Yep, they have the same properties, which means we can apply it for all the edges we have that have the depth of 0.3 millimeter. So the outer of this thing, this thing can use a chamfer because it is the Thunderbolt port. Yep, this thing can use it because it's just 3 millimeter. Of course, this part can also use it. It's like in going in F1 car, you don't want it to take a turn too hard or it might break. I think I have went a little bit overboard with this. We don't need this because it's gonna overlap. Yeah. anything to the interior because it is perfectly fit. That's okay. Okay, nice. Nothing is broken. Save it. This thing can be rounded, but I don't want to. Mainly because yeah, it gonna stick. I want it to sit flush to the surface. But this line, however, we can go wide with it. Let's see how much I can push it. 17mm. This one seems a little bit thin, not gonna lie. Is it, have I overdone this part? You know what? No, it's not. I think it's gonna handle out fine. Let's see if this line have the same thing, how would it behave? Oh, actually much nicer than I expected. I was expecting it breaking. So this means I can also select this line and boom. Dang. Now the printer is really going like an F1 car. Yep, over the goal. Over the goal. Aspect must be rounded out. If I lose it all, lose it all, lose it all. If I lose it all, I'll start as well. I love this. I love the design. Didn't expect I could create something like this, but as you can see, it's not all sunshine and flowers, but even an idiot like me can make it. So do you. And if I can make it on a tool with such terrible UI, you definitely can make it. I believe in you. Okay. Yep. Perfect. Absolutely perfect. Insert Homelander meme, something like that. And let's go back to the part selective. Okay, so fillet 004 fillet. Okay, go to the mirror, select, it is the X and Z. Final operation. Press OK. I forgot the offset. Can I go back? Too much of a hassle. Separate by 50mm. Select the final operation. Okay, what is error? Let go out of the allowed scope. Insert is link object result within. What the? want to go to sleep right now. I should delete this. This is just a test. Okay, save. Yes. This may be the final design. Let's see how well does it slice. Are we losing any details? Cutout looks fine. Let's change it to some color that it's easier to look at. Maybe dark. Okay, much easier to see. Okay, the details seem to be still there. The chamfer still there. Still works. So I'm gonna turn it on, rotate it by 90 degrees, because yep, this is one of the main downside of bed slinger design. Should I just trim this thing super slowly? So like 0.2 millimeter standard. Strength should be definitely not grip and feel. Something like gyroid 3, 4 walls. I haven't experienced with 4 walls yet, but because I saw it have some part in the inside, and let's slice it and see how long does it take. Floating region, okay. Where is it? Only way to know is to enable support, right? What the? Oh yeah, I forgot about that. Totally missed my brain. Skip this part, the floating region. Let's slice again. There is nothing supporting this part. I don't care if it overhang here. Doesn't matter. Doesn't affect anything. This part performance is actually much better than I expect. So this part doesn't affect much. This, yeah, maybe a bit more time with a knife can resolve it, but nothing serious. But this part will definitely fail, so I will need to address this thing. Okay, thank you Slicer for letting me know. Discard modified value. Delete. Flip for 4. Select mode. And deselect this. Okay. Mirror. Final operation. XZ. Offset by 50 millimeter. Hit OK. Click this thing. File. Export. Override. Yes. Flush and rotate. that thing over there was, I can't deliver 17 hours. Calculate the time. What time is it? 17. 5 p.m. tomorrow. So more like 6 p.m. Okay, I can live with that. Let's get printing. I would have to do a bit more prototyping and loading and unloading filament, but that is it, folks. See you when the print is over. Good night.